Seeing as episode 8 on mixed factorization seems to be so popular, I've decided to add a few more examples to show you a few more scenarios of what can happen. So let's have a look at our first one. And again, I'm going to say to you that analysis at the beginning is so important because we've got so many different forms of factorization. If you don't analyze what's going on and make a decision on that basis of how you're going to proceed, then it's actually very difficult to start. So again, even though these look like quite complicated terms, that is a single term and that is a single term. So looking at those two terms, what do we have in common? Well, over here, this is saying 9 multiplied by the bracket x minus y times the bracket x minus y times the bracket x minus y. That's what the cubed is actually telling us. And here we just have a bracket of x minus y. So obviously, common to both of them is the bracket x minus y. So let's have a look at what we have left over. And because there's going to be a bracket left over as well as a coefficient, we're actually going to need to use two types of brackets now. We always use a round bracket, but if we need to use a second type of bracket, then we introduce a square bracket. If you end up using two round brackets within each other, it's not a train smash, but it just makes it much easier to see like this. So having taken out the x minus y, I am left with the 9. And because that cubed meant that I had 3 of these brackets, and I've taken one of them out, it means that I've got that bracket squared left over. And if I multiply back, a bracket squared times a bracket to the power of 1, 2 plus 1 is 3. And then over here, I've taken out the entire bracket, which looks like I've taken out the whole term. And this is again where people often go wrong because they think, oh, that's gone, and they close their bracket. But x minus y goes into the bracket of x minus y once. So don't forget that 1. Now if we look at what we've got, this is a simple binomial, so it's going to stay as it is. But if we have a look at this, we've got one term here and another term there. We've got a minus sign in between, which means it looks like a difference of 2 squares. 9 is a perfect square, a bracket squared is obviously a perfect square, and 1 is definitely a perfect square. So we're going to factorize this using the rules of dots. So I've got square root of 9 is 3, and the square root of a bracket squared, remember square rooting and squaring cancel each other out because they're inverse operations. So I'm just left with one bracket of x minus y. So that's the square root of that entire term. And then I've got minus the square root of 1 is 1. And then remember, in your other bracket with a difference of 2 squares, you'll have exactly the same, except this sign is going to be the opposite. So if we look at that, we could leave it like that, but let's rather multiply these two square brackets out so that we don't have brackets within brackets, because that hasn't simplified things completely. So this one is going to stay the same. And now I don't need my square bracket because I'm going to multiply the round bracket out. So using the distributive law, 3 times x is 3x. 3 times negative y is negative 3y. So we've distributed the 3 into that, and then separate from that is the minus 1. So there's my first bracket that I've now simplified further. The other one, 3 times x is 3x, minus 3 times y is 3y, and then apart from that I have plus 1. And so there is my answer to that, where my initial thing was to take out a common bracket. Then I ended up with a difference of 2 squares which also contained a bracket. But if you just go methodically step by step, you will get to the end product, I'm sure. Let's have a look here. Again, I've got the difference of two things. As soon as I see a p cubed there, and there's no p there that I could take out as a common factor, then I know that I'm dealing with cubes. So this is not going to be the difference of two squares, it's definitely going to be the difference of two cubes. But 16 is not a perfect cube, and neither is 432. So this is where people tend to whip out their calculators, but the more you use your calculator, the less active your brain cells become, and you actually spend more time typing things out on the calculator than just calculating them quickly in your mind. So if you want to work fast and smart, don't allow your mental maths to disappear. Keep it going. And logic as well. So first of all, they're both even numbers, so I straight away think of dividing by 2. If I divided 16 by 2, I would get 8, and 8 is a perfect cube. So this is looking like a very good idea to do. And I hope you're seeing the whole analysis and decision and logic, and then it will lead you to the right thing. So I'm taking out a common factor of 2. 16 divided by 2 is 8. I still have the p cubed. Minus, and now again you could whip out your calculator, or you could just say 2 into 4 goes twice, 2 into 3 goes once, remainder 1, and 2 into 12 goes 6, and that's as quickly as it can be done. So we do have a difference of 2 cubes now, so I still keep out my common factor in the front. Cube root of this term is going to be 2p, retain my sign. The cube root of 216 is 6. Close my binomial bracket, open my trinomial bracket. First term, I say 2p all squared, which will give me 4p squared. This term coming up here has to have the opposite sign to that. And how do I get the term? I multiply those two together. 2 times 6 is 12p. This term will always be positive because I'm going to be squaring something, and 6 squared is 36. And there's your final answer. So let's have a look at something now that's got 4 terms, and if you remember from previous episodes, as soon as we see 4 terms or 6 terms, the possibility is that we're going to be dealing with grouping. So again, let's analyze. Yes, it looks like grouping because there's 4 or 6 terms. If I look at these 2 terms here, I can take out a common 2y. If I look at those 2 terms there, I can take out a common 2b. Some of you might notice straight away that every single term has 2. So if you think about it, I could actually take out a common factor of 2 right at the beginning and then just group the rest. I'm not going to do it like that because I'm going to show you that whether you do it like that, take out the 2 in the beginning, or don't do it like that, but be wide awake later on, you will still get the same answer. So I'm going to decide to group the easiest way, which is first and second, third and fourth. So looking at the first 2, I've got 2y, and from this term I'm left over with y plus, having taken out 2y here, I'm left with a. Remember, when you're grouping, the first term sign is the one that you have to take out. So in the second group, I have to take out a negative. I have a common factor of 2, and I have a common factor of b. So that divided by 2b will leave me with y. Remember, negative divided by negative is positive, or simply remember, if you take out a negative term, the signs in the brackets are going to change. And if I've taken out 2b, I'm left with a. Right, I have a common bracket. I don't have to adjust it in any way. And then I'm left with 2y minus 2b. And as I said, you need to always be wide awake. Whenever you think you've got to the end of a factorization problem, you need to ask yourself, can I go further? That bracket definitely can't go further, but this bracket's got the common 2, which we could have taken out right at the beginning. Seeing as we didn't, we need to take it out now. So even though it's in the second bracket, I'm going to write it in the front because that's conventionally what we do. If you look up here, there's your constant number times a bracket times a bracket. It's just the best way to write it. I'm still left with y plus a. And then having taken out this common factor of 2, I'm left with y minus b. Okay, let's have a look at the last one, which really requires quite a bit of analysis to see how to start. So you're looking at it, you're seeing 4 terms, and you're thinking, okay, that looks like grouping. So then you start to see what can you group, and you're looking at different options, and then you're probably noticing, oh, I've got m's and n's, and then suddenly I've got a q over here. So that should be the clue that this one doesn't fit into the 4 properly. So now let me look at the other 3. What are the other 3 terms actually making up? They are actually making up a trinomial in descending powers of m and ascending powers of n. So I can factorize this trinomial, and then maybe later on I'll see what I'm going to do with that. So I know my trinomial is going to give me 2 brackets. M squared is going to give me m times m, n squared, n times n. The signs in the brackets are the same, and they're both positive. So look what's happened. I've ended up with 2 brackets that are identical. You will start to realize that in certain circumstances you're going to end up with this situation because this trinomial was a perfect square trinomial. And as you become more experienced, you'll spot them and you'll rewrite this straight away in the form that I'm going to down here. But before I do that, never forget to carry everything down to the next step, otherwise you often forget that it exists. So I'm going to rather write m plus n times m plus n as m plus n as the bracket squared, because there are 2 of them, minus 4q squared. And now it should be jumping out at you that this is now turned into a difference of 2 squares, where I've got this as my first term and that is my second term. So all I need to do now is apply the rules. Even though there's a bracket being squared, it doesn't matter. So remember, the bracket squared means the bracket times the bracket. So when I square root the bracket squared, I'm just going to get the bracket once. And I don't have to bracket it again because it's not being squared. It's just m plus n now. Minus, what's the square root of 4q squared? Square root of 4 is 2, and q squared square rooted is just q. In my other bracket, I'll again have the m plus n, and then instead of a minus sign, because it's dots, I'll have a plus sign with exactly that same square root. Right, I hope that has also been helpful, and I would like comments if there are things that you would like me to do more of, and I also ask that you click on the subscribe button so that you can be aware of new things that I'm putting on, as I am trying to put things up as often as possible, if not daily.